Hi, this is Alan. This is a Project Zero Flicker Fusion Threshold. These are the hardware components provided to us. There's a jumper wire kit, and this is a breadboard, and this is the 3.2 TNC microcontroller, and this is the LED bulb, and this is a current limiting resistor. This is 340 ohm resistor, and buttons and the potentiometer. And this current limiting resistor is used because this LED only requires 1.6 volt. This TNC will provide us the 3.2 volts, so it will just kill the LED. So for avoiding killing the LED, so we are using the current limiting resistor, so it will just limit the current, and it will provides a proper source to the LED. And in the coming to the program, I've defined each and every pins of in the connection. So this LED is pin number 2, and I've defined the button pin as in the 4, and in the potentiometer pin in the 21. And this is an integer button state. It's an integer value, and it's a boolean. I've given like it's a boolean function. It's it's a low or it's a high state. And unsigned long is just only shows the integer positive values, not it won't shows the negative ones. And the float function is it's a decimal function, so it will shows the decimal values. And in the void setup, I have given the inputs and outputs. Or inputs and outputs are declared here. In this, the button pin is the input, and the LED is the output. And coming down, and the interrupt service routine, it is a function used here. It's interrupt function is used when the button is acting as an interrupt. So if I pressing the button, so it will just interrupt, and the frequency you can just see in the serial monitor. So it's an interrupt function. And it's a map time is the value received for the potentiometer to be started the value. And it's a map time is a variable to get the precise value from, like, it's 0 to 50,000 microseconds, so it will shows in this range. So this map function is used. And then microseconds, previous time, and this frequency, the frequency is an inverse of time. It's an inverse of time, and it's actively in the period with twice the normal time. And it's divided by 2, so, and it's also multiplied with the microseconds, the value, the 50,000. And in the void ISR, and this is the interrupt service 1. This is the previous button is not equal to the button state, and the button state is low, and the current time minus last bounce debounce time. And the serial print I've given like defined for 6 digits, so frequency from 6 digits, and the serial print, it will just print as hertz. And now I'm just going to upload the program. So uploading the program to the microcontroller. So yeah, it's uploaded. And see, you can see it's you can see the flickering. You can see the flickering. And I'm just giving an interrupt, so it's a flickering is 10 hertz. And now I'm just wearing the potentiometer, so this flickering goes, and you can see this now, the flickering, but it still flickers, so we can just give the interrupt, and we can see the value there. And it's coming around like 39 to 41, yeah, 39 to 41. And this is how this project works. So we can see the flickering through our naked eyes. That's why we are using serial monitor. And this one is also connected to the oscilloscope, so like we can also measure the frequency there. It comes in the falling edge, so it's like measured in the falling edge, like we have done like the same result is there in the oscilloscope. So that's that thing I have just added in my report. And okay, that's all. That's a pro. Thank you.